Hi, Ram. I understand gravity can be a tricky concept to grasp. Let's explore it in a way that makes more sense. Have you ever wondered why things always fall down when you drop them? Why not up or sideways? Let's think about this together. What happens when you throw a ball up in the air? What makes it come back down? That's a good guess, Ram. Gravity is similar to a magnetic force in some ways, but it works a bit differently. Gravity is actually a pulling force that exists between any objects that have mass. The Earth, being very massive, pulls everything toward its center. That's why things fall down instead of floating away. Think of it like this. Imagine you're standing on a trampoline. If you put a heavy bowling ball in the middle, it creates a dip that smaller objects would roll toward. Earth creates a similar kind of dip in space that pulls us toward it. Would you like to see a visualization that might help make this clearer? Great! I've created a visualization to help you understand gravity better. The visualization shows how objects with mass create curves in space, similar to how a heavy ball would create a dip on a stretched sheet. The Earth, being very massive, creates a deep curve that pulls smaller objects, like us, toward it. This is why when you drop something, it falls straight down. It's following this invisible curve created by Earth's mass. Does this help make the concept clearer? What questions do you still have about gravity? Great question, Ram. Gravity actually does change slightly in different places on Earth. Gravity is a bit stronger at the poles than at the equator because the Earth isn't a perfect sphere. It bulges slightly at the equator, making you farther from Earth's center there. Also, areas with denser rock, like mountains, can have slightly stronger gravity than places with less dense materials. Think of it like this. If you weighed yourself with a very precise scale on a mountain and then at sea level, you might weigh a tiny bit more on the mountain. Would you like to see an image that shows how gravity varies across Earth's surface? Here's an image showing how gravity varies across Earth. The red-orange areas, mostly at the poles, show where gravity is slightly stronger, while the blue-green areas, around the equator, show where gravity is a bit weaker. This happens because Earth isn't perfectly round. It bulges slightly at the equator due to its rotation, making you farther from Earth's center there. Also, different rock densities under Earth's surface affect gravity strength in different locations. What do you find most interesting about this variation in gravity? That's a fascinating question, Ram. Your weight would be dramatically different on other planets because each planet has different gravity. On Jupiter, you'd weigh about 2.5 times more than on Earth because Jupiter is much larger with stronger gravity. But on Mars, you'd weigh only about 38% of your Earth weight. You could jump much higher there. The Moon has even less gravity, only about 1/6 of Earth's, which is why astronauts can bounce around so easily on the lunar surface. What planet would you be most curious to experience the gravity of? Jupiter would be quite an experience. On Jupiter, you'd weigh about 2.5 times more than you do on Earth. If you weigh 70 pounds on Earth, you'd feel like you weigh about 175 pounds on Jupiter. This extreme gravity would make it very difficult to move around. Even lifting your arms would feel like they're being pulled down with heavy weights. Walking would be exhausting, and jumping would be nearly impossible. This happens because Jupiter is much more massive than Earth. It's over 300 times more massive, which creates a much stronger gravitational pull. What do you think would be the biggest challenge of living with Jupiter's gravity? You're absolutely right, Ram. Moving around on Jupiter would be extremely difficult with its powerful gravity, and we would definitely need special equipment. Special rovers with extra strong motors and reinforced structures would be necessary since regular Earth vehicles would likely collapse under Jupiter's gravity. Even robots would need to be designed with much stronger materials and more powerful systems. Actually, Jupiter doesn't even have a solid surface we could land on. It's mostly gas. We'd need special floating platforms or airships to explore its atmosphere instead of traditional rovers. That's very insightful thinking about the practical challenges of exploring different planets.